Now quite a simple problem on derivative of an integral. A continuous function f of x is such that 0 to x f of t dt is becoming infinity as x tends to infinity. Then for all constant value k in being a real number, the equation k square x square plus integral 0 to x f of t dt minus a equal to 0, the natural roots of this equation are required, right? Let us consider an equation g of x as k square x square plus integral 0 to x f of t dt minus a. We are discussing the natural roots of g of x equal to 0. Now what are the observations here? One important observation from the definition of g of x is the value of g of 0. What happens when we substitute 0 in this? K square x square would give us 0 plus integral 0 to 0 f of t dt, that is also 0, minus a. So this value is minus a, but a being positive, this value of g of 0 is observed to be a negative number, right? Now the important condition, another observation is from the given condition that integral 0 to x f of t dt is becoming infinity as x tends to infinity. What is limit x tends to infinity for g of x? Yes, k square x square tends to infinity, and from the given condition 0 to infinity f of dt is infinity minus a. So shall we say this also tends to infinity? And also if you observe limit x tends to minus infinity g of x. Yes, again k square x square is at plus infinity. 0 to x minus infinity, but as mod x tends to infinity, this is again an infinite term minus a, so this is also infinity. Now what do we observe here? If you combine this as 2, 3 and f of 0 being negative as 1, at 0 the function is having a negative value g of x, and for minus infinity to plus infinity the graph is tending towards infinity. So what do we observe? The graph starts somewhere and it is crossing a y-axis once between minus infinity and 0, because at 0 it should take a negative value, and again as x tends to infinity plus infinity the graph should go to positive values, so it is crossing x-axis once again, right? It may also be possible that it starts here, then again goes up but comes down for negative values, then again goes up, comes down but goes up again. So if you observe this, we have g of x is changing sign once in minus infinity to 0 and in 0 to plus infinity, right? Now what do we mean by g of x is changing sign from minus infinity to 0? In between minus infinity to 0, the graph is crossing x-axis for an odd number of times. So we'll say g of x is crossing x-axis odd number of times in each of minus infinity to 0 and 0 to infinity. Now as many times the graph crosses x-axis, that many solutions for g of x equal to 0 exist. So we conclude that g of x equal to 0 has odd number of roots in each of minus infinity to 0 and 0 to infinity. If you observe, the option C says odd number of roots in minus infinity to 0 and another odd number of roots in 0 to infinity. And if you remember, the total number of roots of g of x equal to 0 is always even. So what is the option which satisfies? Yes, the option presented C says there are odd number of roots in left side of 0 and odd number of roots on the right side of 0, right?